Have you ever wondered why some metals rust and others don't? Take a deep breath. Feels good, doesn't it? Why am I telling you this? Well, you have a lot more in common with a rusty bike than you think. Maybe you've wondered why you need to charge a laptop or cell phone. Perhaps you've even wondered how some batteries are able to recharge in the first place. Well, the answer lies in the tiniest of particles. It's all about electrons, those teeny tiny parts of atoms that take up virtually no space and have no real mass to really speak of. So, how do they rust my bike? And how do they keep me texting to my friends? Well, it turns out they can actually do some really amazing things. Electrons are strongly attracted to the protons in the nucleus of the atom. Electrons are attracted through the electromagnetic force that exists between two charged particles. Now, some atoms and molecules attract electrons more than others, so electrons often want to move based on which atom or molecule they are most attracted to. So, those electrons really want to move, meaning that they have stored potential energy that we can use to power electronics. When we give them a wire to move through, they release the stored energy, and this is how batteries power cell phones. The problem is, there just never seems to be enough electrons. Cell phones, laptops, tablets all have the same problem. They run out of battery charge. The cells in their batteries go flat when all the electrons have moved to the more attractive chemicals. A sad day for any teenager. But, luckily, we can recharge cell phones by plugging them into a wall. The voltage from the wall gives the electrons the energy they need to get back to the original chemical they were joined to. That means we've recharged the battery and we can go on chatting to our friends again. Now, maybe you've chatted to your friends and you've gone outside to join them on a bike, but you find out that you left your bike outside and now there is rust all over the metal parts. What's up with that? It turns out the same process is going on. Electrons really like oxygen from the air, and the metal in your bike has got electrons that want to move from the iron to the oxygen. When electrons move from iron to oxygen, rust is formed, and that's sad. So, keep your bike out of the rain because the rain helps the electrons move. But why don't all metals rust in the same way? Why doesn't a ship or money rust the same way a bike does? Well, some metals hold on to electrons with a greater force of attraction than the iron in the bike. By understanding the behavior of metals, we can make machines or jewelry that doesn't rust. Now, what's that got to do with me breathing and rusty bikes? Well, the same process that makes bikes rust helps the blood in your arteries carry oxygen to your cells. Well, have you ever wondered why your blood is red? It's kind of rusty colored, isn't it? Especially when you've injured yourself and the blood has dried to make a protective scab. Hemoglobin is a metalloprotein in the blood that allows oxygen from the air to contact iron atoms inside. The two combine because the iron gives up an electron to the oxygen. The oxygen is delivered to cells when the oxygen lets go of the iron, and the iron gives back the electron. So a similar process that happens in rust is the same process that keeps us alive. So, by understanding why electrons move from one chemical to another, we can force them to do work for us. We can even use these processes to make important chemicals like chlorine for the pool or bleach, and help make important metals like aluminium.